March 8, 1942. Somewhere in the vast expanse of the Pacific Ocean, 800 miles southwest of Hawaii. The morning sun cast long shadows across the deck of the Japanese heavy cruiser Tone as Admiral Chuichi Nagumo studied intelligence reports that painted an increasingly troubling picture of American naval capacity. 6 months after Pearl Harbor, Japanese forces had swept across the Pacific with unprecedented speed, capturing Wake Island, the Philippines, and the Dutch East Indies with mechanical precision that had stunned military observers worldwide. But beneath the surface of these tactical victories, darker currents were beginning to emerge that would challenge everything the Imperial Navy believed about American industrial capability. Nagumo possessed the methodical bearing of a career naval officer who had risen through Japan's rigid military hierarchy by trusting experience over assumptions. 32 years of service had taught him to read between the lines of operational reports, to identify patterns that revealed strategic truths beyond immediate tactical success. The telegram that would change his understanding of America's war-making potential had arrived 3 hours earlier from submarine Fuon 26, operating in the shipping lanes between California and Hawaii. Enemy supply vessel captured intact. Request instructions for disposition of cargo and crew. The capture itself represented routine naval warfare, the kind of commerce raiding that had been practiced by every maritime power since the age of sail. But what I-26's commander would discover in the cargo holds of the American merchant vessel SS Montpellier would provide the first comprehensive glimpse into an industrial mobilization that defied everything Japanese planners had calculated about America's capacity for sustained military production. The implications would prove more devastating than any naval battle, more strategic than any tactical victory. Lieutenant Commander Minoru Yokota stood on I-26's conning tower as his submarine approached the captured American vessel through swells that reflected the morning light like hammered steel. 8 years of submarine warfare had taught him to approach every prize with systematic thoroughness, understanding that intelligence value often exceeded the monetary worth of captured cargo. But the Montpellier represented something different. Intelligence reports suggested this wasn't just another merchant ship carrying routine supplies, but a strategic logistics vessel whose cargo manifest would reveal the true scope of American war production. The boarding party that transferred to the American ship carried cameras and documentation equipment along with their weapons, understanding that what they discovered would travel directly to Imperial Navy headquarters in Tokyo, where strategic planners were making critical decisions about resource allocation and operational priorities. Chief Petty Officer Hiroshi Tanaka, 15 years of naval service behind his weathered features, led the systematic inventory of cargo holds that stretched the length of a football field and descended 4 levels into the ship's steel bowels. What they found defied every assumption about American industrial capacity that had shaped Japanese war planning since 1941. Hold number 1 contained 2,847 Thompson submachine guns, still packed in Cosmoline and wooden crates that bore manufacturing dates from the previous month. The weapons represented more firepower than an entire Japanese infantry regiment possessed, yet they were destined for a single Marine battalion operating somewhere in the Pacific theatre. The mathematics were staggering when translated into production capacity measurements. Hold number 2 revealed something even more troubling. Stacked in precise rows that extended beyond the reach of handheld flashlights were 15,000 M1 Garand rifles, each weapon individually wrapped and accompanied by ammunition loads that would sustain a full division through months of sustained combat operations. Tanaka's careful count revealed manufacturing stamps from 17 different American factories, indicating a production network that dwarfed anything Japanese industry had achieved despite years of total war mobilization. The radio equipment filled an entire cargo compartment with electronic sophistication that challenged Japanese understanding of American technological capability. SCR-300 field radios packed in waterproof containers numbered in the thousands, each unit representing communication capability superior to equipment available to Japanese regimental commanders. The vacuum tubes alone, precisely manufactured components that required advanced industrial processes, suggested production capacity that could outfit entire armies while maintaining quality standards that exceeded Japanese military specifications. But it was hold number 4 that provided the most devastating revelation about American industrial mobilization: Jeeps. Hundreds of them stacked in metal cradles that maximized cargo space utilization with engineering efficiency that spoke of systematic mass production planning. Each vehicle bore manufacturing plates from Willys Overland Company, Ford Motor Company, an American Bantam Car Company, indicating a production consortium that had converted civilian automobile manufacturing into military vehicle production, without apparent reduction in output quality or quantity. Yokota examined one of the vehicles with the careful attention of an engineer who understood automotive manufacturing requirements, the precision of component machining, the consistency of metal fabrication, the systematic application of protective coatings suggested industrial processes that operated at scales Japanese planners had dismissed as economically impossible. These weren't handcrafted vehicles produced by skilled artisans working with limited resources. They were mass-produced machines that emerged from assembly lines capable of producing thousands of identical units with mechanical regularity that transformed warfare from a contest of individual skill into an industrial competition. The ammunition holds revealed perhaps the most troubling intelligence about American production capacity. Artillery shells stacked in climate-controlled compartments numbered 47,000 rounds of various calibers, each projectile manufactured to specifications that required precision tooling and quality control systems that Japanese industry struggled to maintain even under peacetime conditions. The brass casings alone represented copper consumption that exceeded Japan's total monthly allocation for military production. Yet these shells were destined for training exercises rather than critical combat operations. Medical supplies filled compartments with pharmaceutical abundance that challenged Japanese understanding of American resource allocation priorities. Morphine, sulfur drugs, surgical instruments, and field medical equipment represented healthcare capability that exceeded what Japanese forces could provide for their own wounded personnel. The implications extended beyond immediate tactical considerations into strategic questions about industrial priorities that could sustain such comprehensive logistical support for forces operating thousands of miles from American territory. Chief Tanaka's documentation revealed systematic patterns that transformed individual cargo discoveries into comprehensive intelligence about American war production. Every manufactured item bore date stamps from the previous 6 months, indicating production schedules that maintained consistent output, despite the massive expansion of military manufacturing that followed Pearl Harbor. Quality control markings suggested inspection systems that maintained peacetime standards even under wartime production pressures that should have compromised manufacturing precision. The spare parts inventory provided final confirmation of American industrial capability that defied Japanese strategic assumptions. Engine components, transmission parts, electrical systems, and mechanical assemblies were packaged with systematic organization that indicated supply chain management, capable of supporting extended operations without reliance on captured enemy equipment or field-expedient repairs. American forces were being sustained by industrial production that treated military equipment as replaceable rather than irreplaceable assets. As evening approached and I-26 prepared to continue its patrol with intelligence that would reshape Japanese understanding of American capability, Yokota found himself staring at documentation that challenged every assumption about America's capacity for sustained military production. The cargo manifest of a single merchant vessel revealed industrial mobilization that operated at scales Japanese planners had considered impossible for any nation to achieve while maintaining civilian economic stability. The mathematics were becoming unavoidably clear, and they pointed toward conclusions that no Japanese naval officer wanted to confront about the true nature of the war they were fighting. The radio message from A-26 reached Admiral Nagumo's flagship at 0347 hours on March 9th, transmitted in the compressed cipher that Japanese submarines used for intelligence reports requiring immediate strategic attention. Yokota's preliminary findings filled 3 pages of typed analysis, each paragraph containing revelations that challenged fundamental assumptions about American industrial capacity that had shaped Imperial Navy war planning since the attack on Pearl Harbor. The numbers spoke with mathematical certainty that transcended cultural bias or wishful thinking about enemy capabilities. Nagumo read the report twice, his methodical nature demanding complete comprehension of intelligence that would influence strategic decisions affecting the entire Pacific campaign. 32 years of naval service had taught him to distrust information that contradicted established doctrine. But Yokota's documentation carried the weight of physical evidence rather than theoretical speculation. These weren't estimates or propaganda claims about American production capacity. They were actual manufactured goods, counted and catalogued by experienced naval personnel who understood the difference between military equipment and industrial theatre. The implications hit Nagumo like depth charges exploding beneath his flagship's keel. If a single American merchant vessel carried enough military equipment to outfit an entire Japanese division, what did that reveal about the total scope of American war production? His staff officers had calculated that Japan's complete annual output of small arms ammunition equaled roughly 60% of what I-26 had discovered in one cargo hold of one ship, traveling one of dozens of shipping routes between American factories and Pacific battlefields. Commander Ryunosuke Kusaka, Nagumo's operations officer, approached with additional intelligence reports that transformed Yokota's findings from isolated incident into systematic pattern of American industrial mobilization. Submarine patrols across the Pacific had intercepted 17 American supply convoys in the previous month, each carrying cargo loads that suggested production capacity operating at scales Japanese intelligence had dismissed as economically impossible for any nation to sustain while maintaining civilian industry. The automotive production figures proved most troubling when translated into strategic implications. Kusaka's analysis revealed that American factories were producing military vehicles at rates that exceeded Japan's total pre-war automobile manufacturing by factors that challenged mathematical comprehension. The Jeeps discovered aboard Montpellier represented less than 6 hours of production from American assembly lines that operated continuously, producing identical vehicles with mechanical precision that transform warfare from artisanal craft into industrial process. But numbers meant nothing without context, and the context emerging from Pacific intelligence gathering painted a picture of American mobilization that operated according to principles Japanese planners had never encountered in their strategic calculations. American forces weren't fighting a war of scarcity where every rifle, every shell, every vehicle represented irreplaceable assets that demanded careful conservation. They were fighting an industrial war where equipment could be replaced faster than it could be destroyed, where logistical abundance eliminated the resource constraints that had shaped Japanese military doctrine for decades. The communications equipment discovered in Montpellier's cargo holds revealed technological superiority that extended beyond simple production capacity into fundamental differences in how American forces coordinated battlefield operations. Japanese units relied on field telephones and runners for communication beyond company level, accepting communication delays as inevitable friction of warfare. American forces possessed radio networks that connected individual soldiers to division commanders through electronic systems that eliminated the fog of war through technological rather than tactical solutions. Medical supply abundance exposed another dimension of American industrial capacity that challenged Japanese understanding of acceptable casualty ratios and battlefield medicine. Japanese military doctrine accepted high casualty rates as inevitable consequence of aggressive tactics, providing minimal medical support because industrial capacity couldn't sustain comprehensive healthcare for combat forces. American medical supply suggested industrial priorities that treated soldier survival as engineering problem, requiring technological rather than philosophical solutions. The ammunition stockpiles forced Nagumo to confront mathematical realities that no amount of tactical brilliance could overcome. Japanese artillery units rationed shells carefully, understanding that industrial production couldn't replace ammunition faster than combat consumed it. American forces possessed ammunition supplies that encouraged wasteful tactics where firepower substituted for tactical finesse, where industrial abundance eliminated the resource discipline that Japanese officers considered essential for military effectiveness. Quality control markings on American equipment revealed manufacturing standards that maintained peacetime precision, despite wartime production pressures that should have forced compromises between quantity and quality. Every component bore inspection stamps indicating systematic quality control that prevented the manufacturing shortcuts Japanese industry had accepted as necessary for meeting military production quotas. American factories were producing military equipment that exceeded Japanese specifications while operating at production rates that Japanese industry couldn't match even with reduced quality standards. The spare parts inventory provided perhaps the most devastating insight into American industrial philosophy. Japanese forces operated under constant awareness that damaged equipment represented permanent capability loss because replacement parts were unavailable through industrial production that prioritized new equipment over maintenance support. American supply systems included spare parts inventories that treated mechanical failure as routine maintenance issue rather than mission-killing equipment loss. Standardization across American manufacturing revealed industrial coordination that achieved efficiency through systematic planning rather than individual excellence. Every rifle used identical ammunition, every radio operated on compatible frequencies, every vehicle required the same maintenance procedures. Japanese forces struggled with equipment diversity that reflected individual manufacturing excellence, but created logistical nightmares where captured parts couldn't be integrated into existing systems. The steel quality of American military equipment challenged Japanese assumptions about resource allocation under wartime conditions. Japan's steel production operated at maximum capacity while struggling to maintain metallurgical quality necessary for military specifications. American steel exceeded Japanese military standards while being applied to equipment that would be discarded rather than repaired when damaged, suggesting industrial capacity that treated high-quality steel as abundant rather than precious resource. Training ammunition discovered aboard Montpellier exposed American military philosophy that emphasized preparation over conservation. Japanese forces received minimal ammunition for training, accepting reduced marksmanship as necessary compromise with industrial limitations. American training ammunition supplies suggested military doctrine that prioritized soldier proficiency over resource conservation, where industrial abundance supported training standards that Japanese forces couldn't afford to maintain. As dawn broke over the Pacific on March 10th, Admiral Nagumo faced intelligence that transformed the strategic landscape of the war he thought Japan was winning. The systematic documentation from Iron 26 revealed American industrial mobilization that operated at scales Japanese planners had never imagined possible, producing military equipment with abundance that eliminated the resource constraints that shaped every Japanese strategic decision. The mathematics were becoming unavoidable, and they pointed toward conclusions about American capability that challenged everything Japanese leadership believed about their prospects for victory in the Pacific War. The technical documentation that accompanied each piece of American equipment revealed manufacturing sophistication that operated beyond simple mass production into systematic engineering excellence that Japanese industry had never achieved even under optimal conditions. Yokota's detailed photographs showed manufacturing tolerances measured in thousandths of inches, precision machining that maintained consistency across thousands of identical components, surface treatments that prevented corrosion through chemical processes Japanese metallurgists had attempted but never perfected at industrial scales. The weapons maintenance manuals discovered in waterproof containers demonstrated American military philosophy that assumed equipment complexity rather than accepting simplicity as necessary compromise with industrial limitations. Japanese small arms were designed for field maintenance using basic tools and minimal spare parts because manufacturing capacity couldn't support sophisticated repair procedures under combat conditions. American maintenance protocols assumed availability of precision tools, replacement components, and technical expertise that transformed equipment servicing from survival necessity into routine maintenance procedure. Nagumo summoned his intelligence staff to the flagship's briefing room at 0800 hours, understanding that Yokota's discoveries required immediate strategic analysis that would influence operational planning across the Pacific Theater. The assembled officers represented Japan's finest naval minds, career professionals who had studied American industrial capacity for decades while developing strategic doctrine based on assumptions that I-26's intelligence was systematically destroying through mathematical reality rather than theoretical speculation. Captain Takeshi Naito, the fleet's senior intelligence officer, had spent 3 years analyzing American manufacturing capability through diplomatic channels reports and commercial intelligence that suggested industrial capacity operating at approximately 40% of Japanese estimates. Yokota's documentation revealed American production that exceeded Japanese maximum estimates by margins that challenged fundamental assumptions about what any nation could achieve while maintaining civilian economic stability and military production simultaneously. The automotive production figures demanded immediate strategic reassessment when translated into battlefield mobility calculations. Japanese forces relied on captured vehicles and horse-drawn transport because domestic production couldn't provide mechanized mobility for infantry units operating across Pacific distances. American forces possessed vehicle abundance that mechanized every aspect of military operations from frontline combat to rear area logistics, eliminating the movement constraints that shaped Japanese tactical doctrine around infantry operations supported by limited, mechanized assets. Communications superiority revealed through radio equipment analysis exposed American battlefield coordination capability that operated through technological rather than tactical solutions to command and control problems. Japanese units accepted communication delays and coordination failures as inevitable friction of warfare because industrial capacity couldn't provide electronic communication systems for formations below regimental level. American radio networks connected individual squad leaders to divisional commanders through electronic systems that eliminated the command delays Japanese officers considered normal aspects of military operations. The steel analysis conducted by the flagship's engineering officer revealed metallurgical quality that exceeded Japanese military specifications while being applied to equipment designed for replacement rather than indefinite service life. Japanese steel production operated at maximum capacity while struggling to maintain quality necessary for critical military applications. American steel was being used for disposable equipment that would be discarded rather than repaired, suggesting industrial capacity that treated high-quality metallurgy as abundant resource rather than strategic limitation. Medical supply abundance forced Japanese medical officers to confront differences in casualty care philosophy that reflected industrial rather than cultural priorities. Japanese military doctrine accepted high casualty rates as inevitable consequence of aggressive tactics because industrial capacity couldn't provide comprehensive medical support for combat forces. American medical supply suggested military planning that treated soldier survival as engineering problem, requiring technological solutions rather than accepting casualty rates as unchangeable aspect of warfare. The ammunition quality control revealed American production standards that maintained precision manufacturing despite production rates that should have forced compromises between quantity and accuracy. Each artillery shell bore inspection markings indicating systematic quality control that prevented the manufacturing variations Japanese ordnance plants accepted as inevitable consequence of wartime production pressures. American factories were producing ammunition that exceeded Japanese specifications while operating at production volumes. Japanese industry couldn't achieve with reduced quality standards. Spare parts inventories exposed American maintenance philosophy that treated mechanical failure as routine occurrence, requiring systematic support rather than mission-ending equipment loss. Japanese forces operated with constant awareness that damaged equipment represented permanent capability reduction because replacement components were unavailable through industrial production that prioritized new equipment over maintenance support. American supply systems included spare parts that outnumbered primary equipment, suggesting manufacturing capacity that could support indefinite operations without equipment degradation through normal wear. The standardization across American equipment revealed industrial coordination that achieved efficiency through systematic planning rather than accepting diversity as consequence of multiple manufacturers competing for military contracts. Japanese equipment suffered from compatibility problems where rifles from different factories required different ammunition, Radios operated on incompatible frequencies, and vehicles needed specialized maintenance procedures that complicated field operations. American standardization eliminated these problems through industrial planning that coordinated multiple manufacturers toward identical specifications. Training equipment quantities discovered aboard Montpellier challenged Japanese assumptions about acceptable preparation standards under wartime resource constraints. Japanese forces received minimal training ammunition because industrial production couldn't support practice that didn't contribute directly to combat effectiveness. American training supplies suggested military doctrine that prioritized soldier proficiency over resource conservation, where industrial abundance supported preparation standards that Japanese commanders considered wasteful luxury, impossible under wartime conditions. The electrical components analysis revealed American technological capability that extended beyond simple manufacturing into systematic research and development that produced military equipment superior to anything Japanese industry had achieved through years of focused military production. Vacuum tubes, precision resistors, and electronic assemblies demonstrated manufacturing processes that required industrial infrastructure Japanese engineers had attempted to develop but never achieved at production scales necessary for military applications. Fuel consumption calculations based on American vehicle specifications exposed logistical capability that supported mechanized operations at scales Japanese planners had dismissed as impossible for any nation to sustain across Pacific distances. American forces possessed fuel abundance that mechanized every aspect of military operations, while Japanese units carefully rationed petroleum products that industrial capacity couldn't provide in quantities sufficient for comprehensive mechanization of combat forces. The textile quality of American uniforms and equipment revealed manufacturing standards that maintained civilian comfort levels, despite wartime production that should have forced acceptance of reduced quality as necessary compromise with resource limitations. Japanese military clothing reflected industrial priorities that emphasized durability over comfort because textile production couldn't provide both qualities simultaneously. American uniforms suggested industrial capacity that eliminated such compromises through manufacturing abundance rather than engineering trade-offs. Captain Naito's analysis revealed patterns that extended beyond individual equipment superiority into systematic differences in how American industry approached wartime production compared to Japanese manufacturing philosophy. American factories had converted civilian production lines to military applications while maintaining peacetime quality standards and increasing output simultaneously. Japanese industry had achieved maximum production through quality compromises and resource substitutions that American manufacturers appeared unnecessary, based on equipment discovered aboard single merchant vessel. The implications crystallized around mathematical reality that no amount of tactical excellence could overcome through traditional military solutions. American industrial capacity was producing military equipment faster than Japanese forces could destroy it, creating strategic situation where battlefield victories became irrelevant because enemy capability increased rather than decreased through combat losses. The war was becoming industrial competition rather than military contest. And Japanese industry was demonstrably losing that competition by margins that tactical brilliance couldn't compensate. As the briefing concluded and Nagumo's staff officers returned to their duties with intelligence that would reshape operational planning across the Pacific Theater, the Admiral found himself contemplating strategic reality that challenged everything Japanese leadership believed about their prospects for victory. The cargo of a single American merchant vessel had revealed industrial mobilization that operated at scales Japanese planners had never imagined possible, producing military abundance that eliminated the resource constraints that shaped every Japanese strategic decision. The mathematics were becoming inescapable, pointing toward conclusions about American capability that would force fundamental reassessment of Japan's to achieve victory through traditional military means in a war that was rapidly becoming contest of industrial capacity rather than battlefield excellence. The strategic planning session that followed would haunt Nagumo's remaining years of service as he watched mathematical projections transform into battlefield reality across the Pacific Theater. Commander Kusaka's calculations revealed production ratios that defied Japanese strategic doctrine built around resource conservation and equipment preservation. American industry was manufacturing military hardware at rates that treated combat losses as statistical variations rather than strategic setbacks requiring careful replacement planning. The metallurgical analysis of American steel components exposed industrial processes that Japanese engineers had attempted to develop but never achieved at production scales necessary for comprehensive military application. Every American rifle barrel, artillery tube, and vehicle chassis demonstrated steel quality that exceeded Japanese military specifications while being produced in quantities that suggested abundant raw material access rather than careful resource allocation. The heat treatment markings alone indicated industrial furnaces operating continuously at temperatures Japanese steel plants could maintain only during peak production periods. Lieutenant Commander Yamamoto, the fleet's logistics officer, provided context that transformed individual equipment discoveries into comprehensive understanding of American supply chain capability. The cargo manifest from Montpellier represented less than 3 days of production from American defense contractors, yet contained enough equipment to sustain Japanese operations for 6 months under current resource allocation constraints. The mathematical implications challenged fundamental assumptions about industrial capacity that any nation could achieve while maintaining civilian economic stability. The weapons manufacturing dates revealed American production scheduling that operated according to principles Japanese industry had never implemented despite years of total war mobilization. Components manufactured in Detroit were assembled in Connecticut, tested in California, and shipped to Pacific destinations through coordination systems that eliminated the production delays Japanese planners accepted as inevitable consequences of wartime manufacturing. American industry had achieved systematic efficiency that Japanese manufacturers pursued but never accomplished at scales necessary for comprehensive military production. Quality-controlled documentation discovered in equipment packaging exposed American manufacturing standards that maintained peacetime precision despite production pressures that should have forced acceptance of reduced specifications as necessary wartime compromise. Every component bore inspection stamps indicating systematic testing that prevented the manufacturing variations Japanese ordnance plants accepted as unavoidable aspects of mass production. American factories were producing military equipment that exceeded Japanese specifications while operating at volumes Japanese industry considered impossible without quality degradation. The electrical systems analysis revealed technological sophistication that extended beyond simple manufacturing into systematic research and development programs that produced military electronics superior to anything Japanese industry had achieved through focused development efforts. American radio components demonstrated precision manufacturing that required industrial processes Japanese engineers had studied but never implemented at production scales necessary for military applications. The vacuum tube quality alone suggested manufacturing capability that operated beyond Japanese technological reach, despite years of concentrated development. Fuel system specifications on captured American vehicles exposed logistical planning that supported mechanized operations at scales Japanese commanders had dismissed as economically impossible for sustained military campaigns. American forces possessed petroleum abundance that mechanized every aspect of combat operations, while Japanese units carefully rationed fuel that domestic production couldn't provide in quantity sufficient for comprehensive mechanization of military forces operating across Pacific distances requiring extended supply lines. The medical equipment analysis forced Japanese medical officers to confront casualty care capabilities that reflected industrial abundance rather than accepting high loss rates as inevitable consequences of aggressive military tactics. American medical supplies suggested planning that treated soldier survival as engineering problem requiring technological solutions rather than philosophical acceptance of casualty rates as unchangeable aspects of warfare determined by tactical doctrine rather than medical capability. Communications equipment specifications revealed American battlefield coordination systems that eliminated command delays through technological solutions rather than accepting communication failures as normal friction of military operations. Japanese units relied on runners and field telephones for coordination beyond company level because industrial capacity couldn't provide electronic communication systems for formations below regimental command. American radio networks connected individual soldiers to division headquarters through systems that maintained real-time coordination impossible under Japanese communication limitations. The ammunition production quality exposed American manufacturing processes that maintained precision specifications despite output rates that should have required acceptance of reduced accuracy as necessary compromise with production volume demands. Each artillery shell demonstrated manufacturing consistency that prevented the projectile variations Japanese ordnance plants accepted as inevitable consequences of wartime production schedules. American ammunition exceeded Japanese military specifications while being produced at volumes Japanese industry couldn't achieve even with reduced quality standards. Spare parts abundance revealed American maintenance philosophy that treated equipment failure as routine occurrence requiring systematic support rather than mission-ending capability loss that demanded careful equipment preservation. Japanese forces operated with constant awareness that damaged equipment represented permanent reduction in combat capability because replacement components were unavailable through industrial production that prioritized new equipment over maintenance support for existing systems. The textile analysis of American uniforms and equipment exposed manufacturing standards that maintained civilian comfort levels despite wartime production that should have forced acceptance of reduced quality as necessary resource conservation measure. Japanese military clothing reflected industrial priorities that emphasized basic durability over comfort, because textile production couldn't provide both qualities simultaneously under resource constraints that demanded constant compromise between competing requirements. Training equipment quantities challenged Japanese assumptions about acceptable preparation standards under wartime conditions, where resource conservation demanded careful allocation between training and combat applications. Japanese forces received minimal practice ammunition because industrial production couldn't support training that didn't contribute directly to immediate combat effectiveness. American training supplies suggested military doctrine that prioritized soldier proficiency over resource conservation through industrial abundance that eliminated such strategic compromises. The automotive components revealed American manufacturing coordination that achieved standardization across multiple producers without sacrificing production efficiency or component quality. Japanese equipment suffered from compatibility problems where different manufacturers produced similar items that couldn't be interchanged due to specification variations that complicated field maintenance and supply distribution. American standardization eliminated these problems through industrial planning that coordinated competing manufacturers toward identical specifications. Electrical component precision demonstrated American technological capability that extended beyond manufacturing into systematic research programs that produced military electronics superior to Japanese equipment, despite years of focused development efforts by Japanese industry. Resistor tolerances, capacitor specifications, and vacuum tube quality indicated manufacturing processes that required industrial infrastructure Japanese engineers had attempted to develop but never achieved at production scales necessary for comprehensive military application. The steel treatment processes revealed American metallurgical capability that produced military equipment using advanced techniques Japanese industry had studied but never implemented at scales necessary for comprehensive military production. Heat treatment markings indicated systematic processes that maintain metallurgical quality across thousands of identical components, while Japanese steel production struggled to maintain consistency, even for critical military applications requiring careful individual attention. Packaging systems exposed American logistics planning that protected equipment during transportation across Pacific distances that Japanese supply systems couldn't reliably traverse without equipment degradation. Waterproof containers, corrosion prevention treatments, and systematic organization indicated supply chain management that eliminated the equipment deterioration Japanese forces accepted as inevitable consequence of extended Pacific operations, requiring months of ocean transport. The manufacturing tolerances discovered through detailed examination revealed American precision that exceeded Japanese capabilities despite production rates that should have prevented maintenance of such exacting specifications. Component measurements indicated systematic quality control that maintained engineering precision across mass production, while Japanese manufacturing accepted tolerance variations as necessary compromise with production volume requirements that demanded reduced specification accuracy. As intelligence analysis continued through the following days, each measurement reinforced conclusions that challenged Japanese strategic planning based on assumptions about American industrial limitation that I-26's discoveries were systematically demolishing through mathematical evidence rather than theoretical speculation. The cargo of single American merchant vessel had exposed industrial mobilization operating at scales Japanese planners had never imagined possible, creating strategic situation where traditional military excellence became insufficient against opponent whose industrial capacity eliminated resource constraints that shaped every Japanese operational decision. The final intelligence summary that reached Imperial Navy headquarters in Tokyo would carry recommendations that no Japanese military leader wanted to confront about the fundamental nature of the war they were fighting against industrial capacity that operated beyond Japanese experience or strategic comprehension. Admiral Nagumo closed the intelligence folder that would haunt his remaining years of service, understanding that the mathematics contained within those pages had already determined the war's outcome regardless of tactical brilliance or strategic innovation. The cargo manifest of a single American merchant vessel had revealed industrial truth that no amount of samurai spirit could overcome through traditional military solutions. American factories were producing victory through mechanical processes that operated beyond Japanese comprehension, creating abundance where Japanese planners had assumed scarcity would provide strategic advantage. The war had transformed from military contest into industrial competition, and Japan was losing that competition by margins that rendered battlefield courage irrelevant against opponents whose manufacturing capacity eliminated every resource constraint that shaped Japanese strategic thinking. 3 years later, as American bombers darkened the skies over Tokyo with mechanical regularity that matched Detroit assembly lines, Nagumo would remember the moment when mathematics revealed what honor refused to acknowledge. The cargo holds of the SS Montpellier had contained Japan's defeat, measured in precision components and calculated in production ratios that determined victory before the first shot was fired in anger.